Well, good afternoon, everyone. It's Salah Sukkarieh here from the University of Sydney. I do apologise for not being there in person. Things just got a bit too busy for me, but I'd like to thank John and the organisers for granting me this opportunity. And what I'm going to be talking to you about is field robotics, which are robots that have to operate 24 hours, 7 days a week in all weather conditions, and their application in agriculture, and give you a bit of a flavour for what's been happening down under in Australia around this. And I'm just going to go through a series of examples of how these robots, along with sensing and machine learning techniques, can really start to do some wonderful things on farm. The first example that I want to be able to look at is tree crops, and which is some of our older work, and it's been going on for quite some time now, but it started about 10 years ago, and looking at what we are being able to do in that space. It was about, as I mentioned before, it was about 10 years ago I approached the tree crop industry and started to ask, whether or not we could start to look at robotics in the context of what it can do on farm. There was a little bit of funding that they could provide, and we had a previous robot here, which you can see on the bottom, the bottom part of this robot here, which is just something that we had from a previous project. They gave us a little bit of funding that we could start to look at mounting different types of sensors and start to have this robot go up and down the rows and look at what it could achieve in terms of collecting all the data. And then with the machine learning algorithms, can we start to do things such as extract features from the environment around us. This is just a movie showing you the kind of results that you can get in real time. So this is just a laser unit. As the robot's going down the row, the laser unit is just being able to detect, along with some algorithms, detect individual trees. And you can start to also map out the terrain underneath the tree, so you can start to get this relationship between what's above ground, and if you have the right sensors to collect information below ground, you can start to get correlations between it and individualize in each piece of information. When you extract that data, the robot then starts to know, okay, this is one tree, and the algorithms allow you to extract that piece of information. And then what you do then is, when you can extract that one individual tree, you can then start to look at the other sensors. Maybe it's vision data, maybe it's infrared data, maybe it's thermal data, and reapply machine learning algorithms around those pieces of information, and start to see whether you can start to look at individual pieces of information. So, for example, this is on a mango farm, and what we've been able to do here is demonstrate the ability to be able to detect each individual fruit, each individual mango fruit on each individual tree. And you can imagine now, if you go through a season, production season, you can start to monitor the growth rate of the individual plant, because you've got the laser data. You can start to get the canopy height, and you start to get the yield estimates, because of the ability to be able to count the mangoes on the tree. And sometimes you miss mangoes because they're within the tree, but you start to get some feel for the relationship between different canopy sizes and the number of fruit, or start to pick up information such as why certain trees don't have enough fruit on them. You can start to do that much early on in the field. We've been able to demonstrate this on a number of different farms, so almonds, mangoes, apples. And you can see here just the relationship between the two, so there'll be ability to be able to detect fruit, and we can do the same thing with flowers and nuts, and be able to do this in real time. And if you can start to do these things in real time, then you start to open up a whole bunch of other areas, such as real-time pollination, real-time pruning as well, which is some of the areas that we're going to look at next. The ability to be able to build up that canopy size also tells you something about, if you want to look at ray tracing techniques, start to look at light penetration. So, for example, how much light is coming into the canopy, and that becomes an important piece of information for optimal pruning. And so what we do know is that farmers try to make that decision between tree structure and architecture, what to prune in order to maximize light coming through. And you can start to get to this point now where if you're building up this digital information, digital trace of a tree, you can then start to look at what the optimal pruning may be. And there's some various strategies around that space, of which we're still early in that research. So I was on tree crops. The next thing that I want to be able to talk to you about is row crops, and in particular the vegetable industry. We've, again, a number of years in that space, and we've gotten to the point now where we've built an operational prototype that we've been taking from farm to farm across Australia, so Queensland, New South Wales, Victoria, Tasmania, so quite a large space, 10 different farms that we have to look at. It's a solar electric robot. On a good day, we will get 24 hours out of it quite easily. If there was no solar charge whatsoever, we'd get about 12 hours. Collection of sensors that sit underneath the robot, looking down at the crop,
And you do the same thing that I showed you before in the tree crops. You start to apply machine learning techniques and seeing what can you gather from that information, what you can learn. So this is just an example of the robot going down the row. This is lettuce, a lettuce farm. The wheel drives here independently, so we can actually go through the headlands quite easily. Here it's detecting the lettuce in real time, and we can start to get growth, the size of lettuce, and also then growth rates in terms of how it's changing day on day. We can get yield estimates as well, so we can start to measure how much plant mass there is. If you can detect the individual plants, then you can also detect where there are weeds, and this is just showing you some initial work that we looked at with a mechanical tine. And that mechanical tine, as you're going down the rows, you can start to detect where the weeds are, and you can start to ruffle up the weeds. And we're looking now at different other mechanical techniques for different size weeds and different types of weeds. This is a Viper unit, which is just what we call Viper anyway, which is just spraying, targeting and spraying, in this case here, corn, each individual plant. And we're going through experiments now of measuring how much fertilizer to put on each individual plant based on growth rate. And here we've got just a water sensor, conductivity sensor, so you can then start to look at sampling next to plants and start to measure the water conductivity. So what it's become now is this 24-hour, 7-day-a-week bot that's starting to collect and measure all this data. The machine learning algorithms are taking us down the path where we're digitizing a lot of that agronomy to be able to have the robot make intelligent decisions in real time as well. This is another example of the robot. In this case here, we're looking at being able to use the same perception software package to do different tasks. So in this case here, all we've done is just added a vacuum cleaner. The same thing here, we're looking for features in the environment that aren't supposed to be there. So in this case here, what if it was a foreign object, and just sucking up the foreign object? So it's just a little toy example, but what it's really showing you is that the whole sensing perception pipeline allows you to plug and play different types of tools into the system. And it says, in order to be able to kind of look at how a robot can be broadened across different parts of the commodity, we took the same robot here and put that, going back to that tree crop example that I showed you before, being able to detect individual apples in this case here, and using the same spray unit that I showed you before, the Viper unit that was spraying corn. In this case here, it's just targeting individual apples and spraying apples. Now, why? Well, farmers can tell you different reasons as to why this would be important. But again, from our perspective as roboticists, we're just trying to show the capability of building up modular systems and using them in different contexts. The next example I want to talk about is the grazing livestock industry. We have some very large farms in different forms, and what you're seeing here is the first initiation of a robot that we call SwagBot, which is to look at low-cost robotics in very difficult terrain. And here we've got the example of the robot coming along and trying to look at what would happen when a robot gets close to the animals and what kind of herding style ends up happening. And you can imagine here, if you're trying to herd cows, I mean, they're not used to this type of bot, so they just run all over the place and go everywhere. So herding in the classic sense of how a human might do it is not going to be the right approach when it comes to these these types of robots. But what we did learn was eventually what happens is the animals get used to it, especially if you start to look at feeding the animals as well at the same time. And so if you train the animals to get used to the robot with some food, then eventually the animals, when they kind of see the cows in this case, when they see the robot and they see it with some food, they'll end up following it. So instead of pushing the animals from one place to another, you start to herd them by doing this kind of Pied Piper approach. And you can start to track the individual animals, which is what's important, because if you can measure the relationship between the animals, where they're eating, the pasture quality, then you can start to look at animal welfare and animal well-being, as well as maximizing yield estimates as well. But the robot doesn't just do animal motion. Here what we're doing is detecting weeds in real time, and this is serrated tussock. And we're actually coming on, in this case here, we're doing some visual surveying techniques to be able to position the robot above a weed and then be able to spray the weed. So even in this complex terrain, you can measure pasture quality, you can measure and look where the weeds are, and you can also start to look at things such as spraying the weeds, which is what this is doing. The final example that I want to go through is smallholder farmers. So, most of the population is actually most farmers are smallholder farmers, and we're looking at low-cost robotic systems. For that, this is a very simple platform where all the smarts are in the wheels and the sensing capability is sitting underneath here. In about 15 minutes, you can
kind of put these robots together, dismantle, remantle, fits into the back of a vehicle, and you can then take it from one farm to another farm. We did a number of different trials. This is using a smartphone and place some algorithms in the smartphone. So try and treat a smartphone as a computer basically. And here we're just detecting individual plants using the smartphone, and then we can start looking at yield estimates as well. We had a look at how this would perform in a developing country, so we took it to Indonesia, and we had some contacts there in a place called Bandung, and we took it to different farms, and we demonstrated the capability of going over different farms and seeing what the farmers were thinking. And it's quite interesting because in developing countries, farmers have the same constraints and problems that we have here. And that led us onto another project that we could start to modify this platform to accommodate for different size type of plantations and different weeds, different size plantations for different crops in different countries. So we went to Fiji and Samoa as well and started to look at how this type of technology could be used in that context. So that's it from me. Hopefully that's given you a bit of an overview of the type of techniques and robotics and machine learning and sensing techniques that we have been working with. I do apologise that I can't be there to answer questions, but feel free to send me an email. My email address is up there, and I'll be happy to answer it. So thank you, and I hope you enjoy the rest of your conference.